Okay, what up, guys? Today we're gonna go over a very important topic, which is solving system of equations using the elimination method. Okay, so this topic is usually the most difficult out of all of the topics that we're gonna be learning in the second semester of 8th grade. Okay, you're gonna see this all over again in high school. That's how important it is. So make sure you understand it now, so that when you go to high school, it's going to be pretty straightforward. I gave you guys a worksheet in the class, and I broke it down step by step. So I'm going to do the same thing right here in this video. So follow along, because this is very confusing at first. Once you first see it, it's like, oh, what are you doing? But once you get the hang of it, obviously this is going to be very easy. In class, I did tell you guys to check your answers using the Desmos app. D-E-S-M-O-S, Desmos. So you can check your answers using Desmos. Okay, so that's one alternative. Okay, so here we go. We're going to go over a couple of examples, and then let's take it from there. So let's give you guys this one right here. So we've been talking about system of equations. Last week or a couple of days before, you guys learned how to solve systems by graphing. There's three types of cases that you could get by graphing. So you could get this case. Boom. When two lines intersect. This is what we call an intersecting line. Intersecting lines. Okay? And they only intersect in one point. Therefore, this one only has one solution. So this is one solution. Then we have another case, a special case, that if you graph it, it looks like this. And hopefully you remember these back in elementary school. These are what we call parallel lines. So these are your parallel lines. Remember, the main goal about systems is, where do these lines intersect? If you're talking about parallel lines, will parallel lines ever intersect? They don't. So that's why parallel lines have no solution. Then we have another type of lines. Okay? They look like this. So I'm going to use two colors. So this is one line right here. Remember, a system is basically two or more lines graphed in the same coordinate plane. The main goal is, where do these lines intersect? Well, then we have this line. What happens if we get another line? It is literally right on top of the other one. They're literally overlapped. That pretty much gives out the name. But they're on top of each other. They're always intersecting all the way from one end to the other. This is what we call overlapping lines. Overlapping lines. Overlapping lines. In some cases, in some books, or in high school, some teachers call it coinciding lines. Coinciding lines. And since they're always intersecting, always intersecting, this has many solutions. Okay? So you have three scenarios. Intersecting lines, which only have one solution. Parallel lines have no solution. And then you have something called coinciding lines, which basically have many solutions. So these are the three types of cases that you could get for a system of equations. And you already saw all of these cases in a couple of days before. Now let's go ahead and start solving some problems. Example number 1. Remember, that bar tells you that these two lines go together. So that's the system. So when you first see it, you're like, oh, I could solve this easily. I could graph these and see where the lines intersect. That will be my answer. But in this case, you haven't learned how to, these lines are in standard form. Standard form is kind of like the opposite of slope-intercept form, which is y equals mx plus b. I haven't taught you how to graph lines in standard form. You could definitely graph them if you learn how to graph standard form equations. But in this case right now in 8th grade, you still don't know how to graph standard forms. So if I can't graph it, then how will I solve it? Because I know these two make a line. That makes a line. That's a make a line. I want to see where they intersect. So the only method that works is called the elimination method. Elimination. Elimination is pretty much the way it sounds. Eliminate. You're going to eliminate some terms. You're going to eliminate some variables. Okay? You're going to cancel them out pretty much. Now, before I start using the elimination method, I like putting numbers in front of the variables. Or I like putting the coefficients. Like, you see that these have coefficients? This y's don't. What number's in front of the y? 1. So I like putting the 1 there. So here we go. Elimination method is like addition. Okay? So we're going to add. So remember in elementary school they taught you how to add like this? You stack them up. 0 plus 3 is 3. 3 plus 2 is 5. Oh, the answer is 53. Well, we're going to stack these up to find out where the lines intersect. Remember, your solution to a system has to be a point. The answers to this problem has to be a point. You want to see where the lines intersect. What x value and what y value do these lines intersect? Your answer has to be a point. So here we go. Let's get started. 2x plus 3x is 5x. So this right here is 5x. Plus 1y minus 1y. Well, they're different signs. Subtract. So these eliminate. They cancel out. You don't have 0y. Don't say 0y. There's no such thing as a 0y or 0x. No, it just cancels out. Equals 7 plus 3 is 10. So keep on going. Divide by 5, divide by 5. X equals 2. And a lot of students today in class are like, oh, that's my answer. X equals 2. No, it's not. This is a system. There's 2 lines you're going to graph, and they intersect at a point. A point has an x value and has a y value. You just found half of the answer. X is 2. Boom. You found half of the answer. Now you need to figure out what y is. So this is how you find y. This is where the tricky part comes in. The way you find y is you choose one of these 2 equations. It doesn't matter which equation you choose. Regardless, you're going to get the same answer. I always try to pick the one with the easier numbers or the ones that always have positives. You see that the top one has all positives. So I'm going to grab this answer. I'm going to copy the first equation. And this is what I'm going to do. I'm going to substitute. So I'm going to get a 2 and put it in for x. Wherever I see an x, I'm going to put a 2 in. So, I see an x right there. So I'm going to substitute the x value. So now it's going to look like this. 2 times, instead of the x, I'm going to put a 2. You see that? I substituted. Plus 1y equals 7. Now it's easy. 2 times 2 is 4. Plus 1y equals 7. Barrier. Circle the variable. Who do I have to get rid of? The positive 4. Inverse operation is negative 4. Negative 4. I'm going to move over here. 1y is equal to 3. Technically, I'm done. You could divide by 1, but at the end, y is equal to 3. Boom! Y is equal to 3. This right here, 2, 3, is my solution. If I graph these 2 lines, you're going to, in Desmos, if you graph them, you're going to see that they intersect at 2, 3. So what type of lines are there? Are they intersecting lines, parallel lines with no solution, or overlapping lines with many solutions? Well, duh, there's one solution here. That means these are intersecting lines. And today in class, I told the students to label it. This is intersecting lines. You found out where 2 lines intersect algebraically. This whole thing is the elimination method. So that's one example. Is that a lot of work? Yeah, it is. But it's pretty easy work. Let's try doing a couple more. Let me just erase the problem. Excuse my board. I haven't cleaned it for a while. Okay. I mean, this type of math is, the more problems you do, the better you become. So let's go over the next one. Let's go over this system. This is example 2. You have 4x plus 8y equals 20. Then you have negative 4x plus 2y equals negative 30. Okay, so that's your next system that you have to solve. This is a system of equations. Some of you guys are like, well, I could graph this and see where they intersect, and that's my answer. Good for you. You could do that. But you don't know how to graph equations in standard form. So the graphing method doesn't work. That means you have to use elimination method. An elimination method is just like adding. It's not always going to be adding, just letting you know. Okay, this is just the first part. We're doing elimination method by addition. There's elimination method by subtraction and multiplication. But that's later videos. So here we go. You ready? 4x minus 4x. Well, they eliminate because they have different signs. They cancel out. 8 plus 2 is 10y equals 20 minus 30. Different signs, subtract. So that will give me 10. Keep the sign of a bigger number. We'll have more negatives. Negative. Divided by 10, divided by 10. Y equals negative 1. And a lot of students are like, I'm done. That's it. No, you're not. A system, the solution for a system is a point. A point has an x value and the y value. You only found out the y value. Now you have to figure out the x value. Okay? So now, this is what a lot of students did today in class. They put, oh, negative 1. Be careful. It's y. Y equals to negative 1. Y equals negative 1. This is negative 1. Y is. Now you decide, okay, now it's the substitution step. That's the step where you pick any of these two, and put in negative 1 for y. So which one do you want to pick? Always pick the easy one. Well, the top one's easy again, right? Because the top one has all positives, no negatives. Okay, so I'm going to pick the top one. 4x plus 8y equals 20. So wherever I see a y, I'm going to put a negative 1. Wherever I see a y. Oh, I see a y here. So I'm going to grab this guy, put it right there. Boom! Substitute. So this is 4x plus 8. Instead of the y, you're going to put a minus 1 equals 20. And then just start solving. 4x positive times negative. And remember when we used to use distributive property, every time you see a negative, it switches the sign. So that was positive, so then it becomes a negative 8 equals 20. Draw the barrier. Circle this. The inverse operation of a negative 8 is a positive 8. Positive 8. Cancels out. 4x equals 28. Divided by 4. Divided by 4. X equals 7. Yeah, 28 divided by 4 is 7. That means you found your x value. X is 7. Boom. That's the answer to the system. That means if you graph these two lines in decimals, you're going to see that these two lines intersect at 7, negative 1. How many solutions is 7, negative 1? Is it one solution, no solution, or many solutions? It's just one solution, so therefore what type of lines are there? They are intersecting lines. So these lines are called intersecting lines. Intersecting lines. And there you go for that one. We're good? Okay, you just need extra examples and then you'll be fine. Let's try to do maybe one more. Then we're going to go over some special cases and that's it. Let's go example number 3. Okay, example 3. Okay, let's go over this one. I'm grabbing these problems from your homework. So let's go over this one. This one's fine. Negative x plus 2y equals 10. X minus 3y equals negative 13. So that's the next one. This is a system of equations. Okay, can I graph them? Well, I know how to graph standard form, but you guys still don't know how to graph standard form. So graphing doesn't work. Therefore, I'm going to use elimination method. But before I use elimination method, remember those variables that don't have coefficients? Put them. They have a coefficient of 1. I like putting them. Okay, addition. What happens to these x's? They eliminate. They cancel out. Out, out. So now this is where you have to be careful. 2y's plus negative 3y's. Same sign or different signs? Different. What do you do with the numbers? Subtract. 3 minus 2 is 1. 1y. But will that y be positive or negative? It's negative. equals 10 minus 13, different sign subtract, 3. Keep the sign of the bigger number, negative. Ooh, be careful with this. We have to get rid of the minus 1. It's multiplying. What's the opposite of multiplication? Division. So you divide by negative 1. Y equals, use the bear for this, negative divided by negative is positive. So y is positive 3. And no, this is not your answer. This is not your solution. Your solution is always a point. Well, sometimes you're going to see when you have a special case, it's not going to be a point. But the majority of the time, it's going to be a point. And the point has an x and it has a y. We figured out the y point. This is the y point. So y is 3. Now I have to figure out x. Well, which one do you want to use for x? Do you want to use the top one or the bottom one? They're both nasty. I can tell you that. I'm going to go over the bottom one. You know? So I'm going to copy the bottom one. 1x minus 3y equals negative 13. There it is. So wherever I see a y here, I'm putting a 3. Where I'm a substitute. So I see a y right there. So now I'm going to copy everything the same. Well, instead of the y, I'm going to put a 3 in. Equals negative 13. Then I'm going to keep on going. 1x. Remember, when there's a negative outside the parentheses, all the signs here change. So negative times positive is negative 9 equals negative 13. Simple. Barrier, circle, plus 9, cancels out. 1x equals, same sign or different signs? Different. So subtract 9, 10, 11, 12, 13, 4. But that 4 is going to be negative 4. So that means x is equal to negative 4. X is equal to negative 4. This is what it means. If you graph these in decimals, they're going to see that they intersect at negative 4, 3. And that's the solution. That's only one solution. That means these lines can be classified as intersecting lines. That's our third example of elimination. Some of you guys are like, well, when are we going to get these cases? Let me give you some examples of those. The special cases are the best ones. You always hope that I give you special cases. And trust me, I will. Maybe only one, because those are easy to solve. So let me show you the first special case. This one. Here's another system. Negative 6x minus 4y equals 1. 6x plus 4y equals minus 10. Okay, so you're like, okay, these are in standard form. I can't graph them. Therefore, elimination method. So let's do elimination method. So I'll put a plus sign here. These cancel out. Click, click. There's no such thing as a 0x, so don't be saying 0x. Wait. Shoot. These also cancel out. Minus 4 and plus 4. So then, Hernandez, what do I have on the left? You have a 0. There's nothing on the left. 1 minus 10. Same sign or different signs? Different, subtract. Will that be a positive 9 or negative 9? Negative. My variables canceled out. I only have 0 equals negative 9. Is that a true statement or false statement? That's false. Because this is false, that means it is no solution. That means if you graph these two lines are going to be parallel lines. These lines will never intersect because they're parallel lines. If they never intersect, they will have no solution. And that's it. You write no solution, you write that they're parallel lines, you're done. That's it. See? That's why you want special cases, because they're so quick to do. Let's do one more. And you can already imagine what case I'm going to give you. It's going to be that one. Okay, let's see this one. Let me see if I have an example for this one. This one right here. See, I'm doing all your homework, literally. This is all homework problems. You're welcome. Negative 2x plus 3y equals minus 8. Okay, here we go. You ask yourself, okay, I can't graph because I don't know how to graph these standard form equations. I know they form lines. I know they're in functions. I can tell you that. I know they're not proportional. I can tell you that too. Hopefully you didn't forget all about that. Okay, so here we go. I have to do the elimination method. Oh, let me use this color. Elimination method, put a plus sign here. Ooh, cancel out. They're gone. Ooh, cancel out. They're gone too. That means we have a 0 right here on the left. Equals. Oh, wait. These also cancel out. 0 equals 0. True statement or false statement? Is 0 equal to 0? Yeah, it's the same number. So since it's a true statement, this has many solutions. You see the difference between parallel and many solutions? Parallel lines have no solution. These have many solutions, and because it has many solutions, we call these overlapping lines. Overlapping lines. They're going to look like those lines. That means if you graph these two lines in decimals, they're going to be two lines, literally on top of each other forever, 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 because they're identical. They never change. So that's when you have overlapping lines. You could also call them coinciding lines. It means the same thing. And then you have many solutions. Again, let me recap. When the lines intersect, that means one solution. They're intersecting lines. When they never intersect, there's no solution. They're called parallel lines. And then if they're overlapping, they're always identical. That is called many solutions. Again, this is called elimination method. This is one part of the elimination method. That's the easiest part. Then the next future videos, it's going to get difficult, more difficult, and more difficult. But, I mean, it's pretty easy. It's the same steps, okay? So again, this is elimination method by addition. And I'll see you on the next video.